cubic silicon carbide. This is one of the silicon carbide which is very, very, very interesting, especially from research point of view, because it's so difficult to master how to control to get good quality cubic silicon carbide over a large area. And in the 90s, when I was a young PhD student, the 6-stage silicon carbide polytype was the most stable one, and it was possible to get it to form. And there were some polytype mixtures of 6H and 4H in the bulk growth, and some 15R and so on. And over time, the 6H silicon carbide polytype was possible to control. So it was single crystal of only one polytype, and then you had other polytypes at the edge, and then you broadened the good area of 6H silicon carbide. And this is due to the stability of the 6H silicon carbide. It's more stable at high temperatures than the other polytypes. So it's very natural that it forms first. Then the growth of 4H matured, and it was originally growth on the carbon phase of 6H silicon carbide and things like that. And there were small areas, and you could expand it, and then 4H silicon carbide became also fairly stable at that time. And this polytype has more interest for the devices than the 6H silicon carbide. And then the cubic silicon carbide has always been explored, but it's so difficult to grow that it never matured to bulk growth. And it has certain conditions in order to form. It prefers a silicon-rich environment, lower growth temperatures, and at lower growth temperatures you cannot grow with high growth rate. Then it's difficult to get bulk growth and all those things. And in the 1990s and those years, the golden years, there was a lot of interest and funding, EU funding, Swedish national funding. Industries were actively participating in funding activities. So then funding was easy, sort of, in comparison. And then it was so much challenges with the material development that things took time and funding decreased, and for sure in Sweden. And those things have been mastered, and now there is 4H silicon carbide wafers in a large area and fairly good quality, at least so there can be devices and systems made out of it. And it's a big market. But it means that it has matured to an industrial stage for certain application. And then the poor little cubic silicon carbide still suffers because there's so much things to master in the growth. You can get high quality areas which can be broader, but then you have different domains which makes problems. So it's still very challenging. And there is no big application for the cubic silicon carbide which is recognized and appreciated by industry. So they want to put in money to the research to develop the cubic silicon carbide. So there's a gap there. Super nice research interest. That's great. From industrial point of view, it's too early stage. And now when silicon carbide is industry, then it's so difficult to get fundamental research projects. And in Sweden, this is hopeless. In Europe, it is not totally hopeless because there are some exciting projects, but we need to motivate them because they are like emerging technologies for the future. And I participate in a EU FET Open SiComb on frequency comb and ideas like that. So they are still appreciated, but it's difficult to get funding if you compare so on. So even though there are nice research topics related to silicon carbide, still, then it's the balance of how to get the funding, how to get the industry interest so we can create the value chain from the fundamental researchers in the material growth to the industries and propose consortia and things like that. So this is a balance. But for us who are super excited about silicon carbide, we continue to move on and find new collaborations, Europe, Asia, and other places where it's relevant, and maybe even one day Africa will be active, and that I'm very interested in, because then we could make new research, educate people in Africa about these things, and then it will start to grow, and then one day it will be very fast development, and then we have new technologies from new research in Africa and new technologies and things like that. So still, even it's almost 30 years and I started with silicon carbide fundamental research, and now active in the innovation, capacity, transfer of knowledge and such things, then it's still exciting to find novel approaches using the silicon carbide. It's the R&D and innovation which strives me to continue to find partnerships and do interesting things. And cubic silicon carbide is one of those which I still believe in.